Okay, we're looking at waveforms here, and specifically the resampling of waveforms. This is the best sample rate converter out there. This is by Isotope, and we're just going to see what it looks like when they go from like 192 to 96, like right there, and then to 48. And then to 44.1. So you can see the samples, obviously the dots. The line in between is the waveform that results from connecting those dots. And it's not always the same, and that's what we're going to show you in this video. Notice how there's a slight, if you look on the right, there's a slight change in shape. 48, 44. We'll see why this is important. Most of the time it's not something you can hear, but you can see that it will be important when you get to the 0 level. When you go from 96 to 44.1, the intersample peaks, what they're called, will be able to be raised just by the fact of resampling. So that's another reason not to go to 0. Here's one of those cutoff waveforms. You look on the right, this is 192. Look on the right side of the screen there where the waveform ends the picture. There's 96. You can see how it changes. 192, 196. There's 48. And there's 96, 48. See how the waveform changes? That's at high frequencies, so that's not critical. But what you can see is that the waveform peak in between the samples can be different than the sample, and that's what we're looking at. There's 48, 96, 48. 96, 48, see that? How it changes the waveform and it raises up, and if you're at 0, you're going into distortion. '96, 48. See, it's pretty interesting to see how that works. Here's 192, 48. 44, and then we'll look at the others. 176, cut that in half, and you go to 88. You see how it changes there? It's just cutting it in half. That's very simple. And then 88 to 44. 88, 44, 88, 44. And see how it changes. There's 192 again, still looking at the right side. I think on this one the right channel will be the most dramatic. That's the lower one on the right side. There's 176. It's just we'll just go through all the samples. You can just see how it changes. 192, 176, 96, 48, and 44. You can see how that changes, and you'll notice the height differences on the inner sample peak is what we're looking at. It changes. Again, not critical when you're not near the limit, but if you're at 0, then it's critical. Here's a zoom in. This is a 192 kilohertz waveform. There's a 96. There's a 48 and 44. That's all the same waveform, just resampled. 96, 48, 44. Isn't that interesting? It's the exact same waveform, exact same spot. Here's another one. Again, if you look on the right hand side, it's easiest to see. Just showing you, can see how now you look at the shape of that waveform, it's a little bit different. There's 44, there's 192, 96, 48, 44. So you can just see that's what resampling does. It's not a big deal. It's only a big deal when you're at when your sample's already at 0 at the limit. Now we're looking at a chart of the true peak and sample peak waveform levels for the same piece of music. This was just the two of us from HD tracks in 192 kilohertz version, and they squashed it up against the wall there, and so this is the actual measurements of the highest points in the intersample, which is true peak, and the sample peak. And so the 192, you can see left and right minus 1/100th of a dB and 300ths on the true peak intersample, and then the sample peaks are minus 100 on the left, 100th, and on the right 2/10, minus 2/10 dB on the right. So we resample that to 96, cut it in half as far as the sample number, and then we have, just as a result of doing that, and remember this is still the best sample rate converter out there, so others are worse. Others will have more problems. So this is just a function of sample rate conversion. It's not a fault of any program. But the left is minus 9/100ths, right is minus 6/100ths on the true peak, and virtually the same on the sample peak, which of course that's different than the 192 version. We take that 96 kilohertz sample and we resample it to 44.1. Takes a little more math. We got to cut it in half and then change it to a different equation to get to 44.1, and we've got now in the left channel the intersample true peak is plus 0.21 decibels, and in the right channel plus 0.31 decibels, which results, because remember those are pretty close to 0, virtually 0. We look over at the clip samples, and now we got a problem. Left channel has 28 samples that are above the limit, the digital limit of 0, and right channel has 323 samples above that limit. We haven't changed the volume. You look over there at minus 12.7. Nothing's changed there. All we've done is resampled it from 192 down to 44.1, and the end result is a bunch of clipped samples. So what we saw when we were looking at the pictures of the waveforms where the intersample line went up beyond the level of the samples, you can see here, and this is the result. So if you have something in this case done wrong, pushed up virtually 0, as it's resampled, it will come up with overages, digital overs, which are not a good thing at all. Okay, so that's why we don't go to 0. We try to stay at -1, and you won't have any trouble. We could look at the amounts in other places, other songs, and so on, but The picture here you can see over 3/10 of a dB the intersample rate has risen above the sample peak, and the end result, since the sample peak was already at virtually zero, it ended up in clip samples, and you can see what a problem that would be in the digital world. So that's why you don't do it. So I hope we've all learned something here, and until next time.